implement the following expression. Anytime we're implementing a problem like this, we have to look first at the brackets. We have to check how many pairs of brackets I have in the expressions. I have one pair, and this is the second pair. Okay, each pair represents a separate part of the circuit, so I can say I have two parts of the circuit. I'm going to start implementing from the expressions which are inside of the brackets, okay, inside of the parentheses also. So that's why I'm going to have, first, I'm going to have NAND gate, which has inputs A, B. This is NAND gate A, B, and this is AND with the bar over A, B, so this is nothing else, just the NAND gate. That NAND gate is exclusively NOR with C. That's why I'm going to connect C to the exclusive NOR gate together with my NAND gate. I finished these parentheses. Now let's check what I'm going to have in these parentheses. Okay, I have AND gate, but A goes with the inverter. So I have AND gate and A goes with the inverter. I have D, okay, and output of the AND gate is ORed with C node. That's why I'm going to have over here inverter. Okay. ORed with C node, and the whole circuit, which I got from here, is exclusively NORed with D. That's why I'm going to have D over here. D, and this is exclusive NOR. Why? Because this is exclusive OR sign, and remember we have to treat these parentheses like in one term, and this is my second term, so this bar belongs to this sign. That's why this is exclusive NOR gate. I finished with the parentheses which are inside of the brackets. So next I have to join them together. Okay, these two terms are joined together by the OR gate. That's why I'm going to connect these two circuits to the OR gate. Okay, now let's check what we have over here. I have AND gate with two inputs A and D node. So I'm going to have AND gate with input A, and I have also D node. Okay, and I have another AND gate with inputs CB, okay, and this AND gate is NORed with D. So I have, this is going to be my D, okay, and it's NORed, okay, is NORed with D. Okay, now this gate is NANDed with this part of the circuit, with this expression. Okay, why? Because I have multiplication over here and I have bar over these two expressions. That's why I have NAND gate over here. Now I finished I finished with these brackets and I finished with these brackets. Now, these two brackets, as I said before, are joined by NAND gate, because this is nothing else than the multiplication. Anytime we have no sign, there is multiplication. So this is AND, and because I have bar over the whole expression, this is going to be NAND. That's why these two circuits are joined together by the NAND gate. And this is my solution. Let's prove that whatever I did is correct. Okay, so, but before I'm going to prove, I would like to just remind you that anytime I see A, it means that there is physical connection if it comes to the real circuit, that there is physical connection between this A and this one, okay, means all of them are connected together. If it comes to B's, this B is connected with this B, okay, I don't see any other B's, and let's say this C is connected with this C and this C, and these are also connected together, okay. I just do not want to mess up the picture, that's why I didn't connect them. Now, let's check what function I'm going to have at the output of NAND gate. I have AB NAND. That's why I'm going to have A, B, NAND. This is my C. This is exclusive NOR. That's why I'm going to have over here A, B, NOT, exclusively NOT with C. As you can see, we got exactly the same expression like this one inside of the parentheses. Now, let's look at this part of the circuit. I have A, this is going to be A naught, this is D. The output of the AND gate, I'm going to have A naught, D. Over here I'm going to have C naught. That's why I'm going to have over here A naught, D, or C naught. Okay, as you can see, I got exactly the same thing like we have over here inside of the parentheses. Now, this is D over here. At the output of this gate, I'm going to have exclusive NOR of whatever I got at the first input and the second input. So I'm going to have over here A naught, D, or C naught, and exclusively NOT with D. Okay, so this is basically what I have over here. Now, so again, just take a look what we have got over here. We have this expression, and this is what we had at the beginning. It's exactly the same. Now, let's find what we are going to have at the output of the OR gate. Simply, I'm going to OR this expression with this one. That's why I'm going to have, can write brackets, open parentheses, A, B, NAND, exclusively NOR with C, okay, and this is OR with whatever I have got over here. So this is A naught, D, or C naught, and I have exclusively NOT with D, okay, and I have parentheses over here, and I can close the brackets over here. Okay, now let's take a look what we are going to have over here. I have D naught, and I have A and with D naught. At the output of this gate, I'm going to have C, B. This is D, so my D is going to go over here. At the output of this gate, I'm going to have C, B, NOR D. So this is CD, NOR D. Okay, so at the output of this gate, I'm going to have this expression NAND with this one. That's why I'm going to have over here A, D naught, side of the parenthesis, and NAND with C, B, or NOR with D, and has to be NANDed. That's why I'm going to have NAND over here. Now, as you can see, whatever we have over here, right, is exactly the same thing which we have over here. Okay? Now, let's write the final answer, okay? So, simply I'm going to NAND this expression with this one. And I'm going to have A, B NAND, exclusive NOR with C, okay, parenthesis, or open parenthesis, A naught D, or C naught D, close parenthesis, okay, has to be exclusive NOR with D, I suppose to say, close the bracket, okay, and times, okay, I hope I'm going to have enough space over here, and this is going to be A, D naught, and over here I'm going to have C, B, or D naught, okay, close parenthesis and close bracket, and everything is NAND, okay, and the NAND gate is telling me that I'm supposed to draw the long bar over the whole expression. Okay, as you can see, the expression which we got at the beginning, right, we get exactly the same form at the output of the circuit. It means that whatever I have drawn on the board is correct. This is the answer to the problem.